Good morning, distinguished guests, dear professors, my dear friends. My name is Daneti Arun Sourya. I am joint PhD program student from IAHS Hyderabad, Sunman University. Today I am going to present my work, Can blended models offer a better approach for streamflow prediction in large sample study? Hydrological models plays a vital role in water source management, streamflow simulation. Hydrological models are divided into process-based models, physics-based models, deep learning models. Each model has their advantages and disadvantages. So, in a particular at present, in a particular catchment, there is no proper benchmark to identify the model is performed well or not in a particular catchment. So for that, recently no one has published 17 different benchmark models. We have used those models in order to identify a certain threshold. Is that model is performed well in that particular catchment or not? And in hybrid combinations, it's a booming topic to improve the streamflow simulations. But in hybrid combinations, everyone are using every process-based model output to the LSTM model. Now, the key important thing was if process-based model is not performed well in the particular catchment, by giving that output, there is no much improvement. So why to consider that? So in that, this raised me questions, and to use that, we identified certain objectives like identify catchments where process-based model output performs better than benchmark model, and deep learning model is not perform well than benchmark model. So in that catchments, if you use this hybrid combination, is there an improvement or not? And based on catchment characteristics, can we select any hybrid combination? For that, we used in this study we used 3 process-based models: GR4G, HPV, SAC-SMA, and 1 LSTM model. Before running these, we ran 17 different hybrid benchmark models. From that, we identified the maximum kg value. From that maximum kg value, we added certain value 0.05 and created as positive threshold. We subtracted certain value and created as negative threshold. Now, in catchment, where process-based model output is greater than positive threshold, in that particular catchment, where LSTM model output is less than negative threshold, in those catchments, by developing this hybrid combination, is there an improvement or not? We are trying to check. For hybrid combination, we used output soil moisture and discharge to the LSTM model from the from the process-based models, and we are observing any improvement or not. Now, from these solutions, we identified that in LSTM model, when we are running with meteorological data, we observed 52% is there in fair range. Fair range is the kg value is between 0 to 0.3. Now, by using this hybrid combination, we are observing in good range from 0.3 to 0.7. So we are identifying that soil moisture is one of the key important variable. From feature importance plot, we identified that one of the key important variable is soil moisture and stream flow. Further, we use satellite soil moisture data and identified that in those catchments, by using satellite soil moisture data, we also observed there is an improvement. Now, using these hybrid combinations, but this satellite is not giving that much improvement as like process-based model output because of certain gaps. We identified certain conclusions like in LSTM SAC-SMA hybrid model is working well in medium snow fractions, and LSTM GR4J working well in low snow fractions, and LSTM HB working well with medium elevation. That's what our key findings. Thanks for giving me this opportunity for presenting this work. Thank you.